The definition of 5 squared is 5 multiplied by 5, or 25. And for 5 cubed, that's just 5 times 5 times by 5, which is 125. But what if we wanted to find out what 5 to the power of 1 was? Well, that's not as obvious, but we can use this pattern to kind of help us out. So to go from 25 to 125, you just multiply by 5 again. So it makes sense that the pattern is multiply by 5 as you increase this number. So to go backwards, we just need to divide by 5. So if we follow this pattern on, we need to do 25 divided by 5, and that will give us 5 to the power of 1 is just 5. And then we can continue that into 5 to the power of 0. So we continue our pattern, dividing by 5. We get 5 to the power of 0 is 1. Then we can go further, and 5 to the power of minus 1 is going to be 1 divided by 5, which, to keep it simple, let's just leave that as 1 over 5. And then we could also do 5 to the power of minus 2, which would be the same as taking 1/5 and dividing it by 5 again. So following that pattern on, and we would get that's 1 over 5 times 5, which is the same as 1 over 25, which it's not a coincidence that that's actually the same as 1 over 5 squared. So from this pattern, we can say in general that if we have a to the power of minus m, that's the same as 1 over a to the power of m. Or sometimes you might have it with a fraction where we have, let's say, b over a to the power of minus m, then that would be the same as a over b to the power of m. So either you get 1 over your original number when you raise it to a negative power, or you flip over the fraction and then raise it to the power. So we can look at some quick examples that show this in action. So if we had 4 to the power of minus 2, if we look at this top example here, that means we're going to have 1 over 4 to the power of 2, which would just be 1 over 4 times 4, which is 16. And then if we look at one with a fraction, let's say we had 3 over 2 to the power of minus 3. So that means because of the minus, we need to flip over the fraction. So we'd have 2 over 3, and then that would be to the power of 3. When we have a fraction raised to the power, all we do is just take each part to the power of 3. So 2 to the power of 3 is 2 times 2 times 2, which is 8, over 3 times 3, which is 9, multiplied by 3 again, is 27. For this next part, I'm just going to give us the definition that if we have a number raised to the power of a fraction, that's the same as finding the root of the denominator of that fraction. So a to the power of 1 over m is the same as the nth root of a. So if we put some numbers, it's a little bit easier to see. If we have 9 to the power of a half, that's the same as finding the second root, or the square root of 9. So what times 9, what number multiplied by itself twice gives us 9, which would be 3. Also, if we had something like 27 to the power of 2/3, here we just deal with the denominator part first. So we've really got 27 to the power of 1/3, and then we're going to square our answer. So 27 to the power of 1/3, from this definition above, we need to find the third root of 27, and then after we've done that, we're going to square our answer. So the cube root of 27 would be 3, and then we need to square that, which would give us 9. Now we're going to look at some examples that combine negative and fractional indices. If I have 1 over 16 all to the power of minus 3 over 2, I'm going to need to use the rules I've just looked at to help me simplify this. So the first thing I'm going to do is deal with that negative. So because I've got a negative power, that means I need to flip over this fraction. So I'm going to get 16 over 1 all to the power of 3 over 2. Now really, I don't need to write 16 over 1, so I could have just written that as 16. So the next bit, just as before, we're going to deal with the denominator first. So if I've got 16 to the power of 3 over 2, that's really the same as finding the square root of 16 and then cubing my answer. So the square root of 16 would be 4, and then I need to find 4 cubed. 4 cubed is 4 times 4 times 4, which is 64. So we can say that 1 over 16 to the power of minus 3 over 2 is the same as 64. Okay, now for my second example, we're going to look at something a little bit more complicated. So let's say I had the 6th root of 64x to the 6, all divided by the 4th root of x. So there's quite a lot going on here, so we'll try and split it up and make it as simple as possible. So if we're looking for the 6th root of 64x to the power of 6, we need to split that down into the algebra and the numbers. So we need to find the 6th root of 64, and that's going to be multiplied by the 6th root of x to the power of 6 all over the 4th root of x. So then we've got the 6th root of 64, I know is 2, and that's multiplied by the 6th root of x to the power of 6. So it makes sense that if I need to multiply something by itself 6 times to get to x to the power of 6, that must be x, or we could say x to the power of 1. And that's going to be divided by, well, where we've got the 4th root of x, we know from our previous rules that I could actually rewrite that as x to the power of a quarter, because that's the same as finding the 4th root of x. So we're nearly finished now. I'm just going to rewrite this fraction in a slightly different way. I could rewrite it as 2x to the power of 1 divided by x to the quarter. And I think this makes it a little bit clearer to see that this is just our regular GCSE index laws here, because when I divide by a power with the same base, I can just subtract. So 1 take away a quarter would be the same as 2x to the power of 3 over 4. There we go.